to True Projects. In this video, we are going to discuss about the project which is brain tumor detection using machine learning. So let's understand what is the project about. What are these brain tumors? Brain tumors, they're nothing but they are abnormal growths of tissue that can develop inside the brain or the central spinal canal. So these brain tumors, they can vary in different sizes, locations, and how fast they grow. If a person has a brain tumor, it can cause different kinds of problems depending on where this brain tumor is. For example, it might make it hard for them to remember things. That means person get memory loss and he can't speak properly, or even some may get paralyzed if they are affected by this brain tumor. On top of that, brain tumors can also affect person's emotions, making them feel anxious or depressed. In severe cases, these problems can be really serious, which makes difficult for someone to do everyday things like walking or talking. So detecting these brain tumors is really important because it helps doctors to decide the best way to treat them and give the person the best chance of getting better. But the usual methods of finding brain tumors like MRI and CT scans, these take long time and cost a lot of money. That's where machine learning comes into the picture. So, machine learning is a way of teaching computers to spot patterns in lots of data. By using machine learning, we accurately and efficiently detect whether a person is affected with a brain tumor or not. Moving on to the flow of work, that is the procedure used in the project to implement. So first we need data, right? So we will gather bunch of brain MRI scans to train our system. Once we have these images, we will process them to make sure that they are in a format that computer can understand. Now we can't just use all the data at once. So we need to split the data into two groups, one for training our system and the other one for testing how well it works. So we divide the data set into training set and the other one is testing set. This helps to ensure that our system can handle new data it hasn't seen before. So next, we will try out different machine learning algorithms to see which one works best for detecting brain tumors. Well, we will test algorithms like random forest, gradient boosting, decision trees, KNN, and voting classifier. So these algorithms, they basically learn from the data and make predictions. So to figure out which algorithm is best, we will use metrics like accuracy, precision, recall, and F1 score. So these tell us that how well our system is performing in terms of finding brain tumors accurately and efficiently. Once we found out the best performing algorithm, we will integrate into user-friendly interface that is Flask. So best performing model is voting classifier. So that is integrated into the front end to deploy the project. So we have used the framework called Flask to build the web application, which is integrated with SQLite. With this, with this interface, users can easily upload their MRI scans and get automated results about whether they have a brain tumor or not. It is all about making the process as simple and accessible as possible for both patients as well as medical professionals. So moving on, to implement this project, we need software and hardware requirements. So coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So coming to the hardware requirements, we need Windows operating system, i5 and above processor, 8 GB and above RAM, 25 GB and above hard disk. Moving on to the algorithms used, these are the algorithms which are built in the project. So we have built random forest, gradient boosting, decision tree, KNN, and voting classifier. So among all the models built, voting classifier achieved highest performance. So we have deployed it in the front end. So let's understand what is this voting classifier. Voting classifier is an ensemble learning technique where predictions from multiple individual models are combined to make a final prediction. Here we have combined decision trees, random forest, and gradient boosting. Each model detects brain tumor on the input image, and the voting classifier aggregates these predictions based on a majority vote or a weighted combination of these individual predictions to make a final decision. Each model's prediction is treated as a vote by leveraging the collective intelligence of multiple models. The voting classifier aims to enhance the accuracy and robustness of brain tumor detection, potentially outperforming any single model alone. So now let's execute the project. To execute it, first we have to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Before execution, let us understand all these files, how will they be used in the project. Here in the first folder, which is archive, we have the data set. So open it. Here we have two subfolders. One is train and the other one is valid. In train, we have two more subfolders. So these are two different classes of brain tumor. One is the person having brain tumor and the other one is having no brain tumor. So open the S folder. So these are the brain MRI images which has brain tumor in it. And in no folder, these are the brain MRI images which has no brain tumor. So we'll be using both of these folders to train all the models in the project to detect whether person is having brain tumor or not. So get back. Similarly, we have a valid folder also. We can observe that there are yes and no folders. So we'll be using train folder to train the models and valid folder to evaluate how the algorithms has detected. So now get back. In sample folder, we have two subfolders. One is yes and no. These are the test cases folder. So we'll be using these images for detecting brain tumor in the front end. So these are the images of brain tumor and these are the images of no brain tumor. So we'll be using these images as test cases. Get back. Moving on to the static folder. This folder contains files related to project styling and interactivity. They are CSS, JavaScript, and Bootstrap files. The next folder is templates folder. Here are all the HTML pages utilized in the project. They are index.html, about.html, etc. Each HTML file represents a different page of the website and provides structure and layout for displaying content to the users. So here we have app.py file. This Python file encompasses front-end logic of the project. It handles operations, that is server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And this is the model file which contain the algorithm information, and this will be loaded into the project code during runtime. And these are also model files. So coming to the notebook.ipynb file, this is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. And the last file is signup.db file. This file is a database file which is used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So copy the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folder's path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and it will perform a runtime check for any syntax errors or logical issues. After running app.py file, Flask framework will host the application locally at the local host and port. So this is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. So paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. So we need to sign up, click on sign up and enter all the registration details if we are registering newly. I have already registered and I have an account in it. So I'll directly sign in. So click on sign in and give the username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page. Here we can see a choose file button. We need to click on that for uploading the brain MRI images. So click on choose file. In the sample folder, we have the test cases for detecting the brain tumor. So first we will upload images from yes folder. So open it. Yes means that person has brain tumor. So let's see. whether application predicts brain tumor or not. So I'm going to upload the first image. Click on open. Here we can observe that image is loaded. Now upload it. So this is the uploaded image, and here we got the prediction as, for the given input image, the patient is diagnosed as tumor. That means that person has brain tumor. We can observe that application has correctly detected. So we will try using some more images. Click on try again. Click on choose file. So we will see with this image. So click on open and now upload. So here also the application has correctly predicted as the person has been diagnosed with brain tumor. So we will try using some more images. Click on try again. Click on choose file. So now we will be uploading this image. Click on open and now upload it. So here we got the prediction as, from the given input image, the patient is diagnosed as tumor, which means that person has brain tumor. So now we will upload images from the other folder. Click on try again. Click on choose file. So we will upload images from the no folder. So these are the images where there is no brain tumor. So let's see whether application will detect as there is no brain tumor or brain tumor. So select the first image, click on open and now upload it. So this is the uploaded image, and here it has correctly predicted as there is no brain tumor. We will try using some more images. Click on try again. Click on choose file. So we'll upload this image. So this is the uploaded image and it has predicted as no tumor. We'll upload one more. Click on choose file. So we'll be uploading this image. So this is the uploaded image. So for the given input image, the patient is diagnosed as no tumor. That means the person has no brain tumor. So we will try using some more images. Click on try again. Now we'll upload from the other folder, that is yes folder. So I'll be uploading this image. Here we got the prediction as the patient is diagnosed with brain tumor. We'll try with some more images. So I'm going to upload this image. Click on open and now upload it. So this is the uploaded image, and here we got the prediction as the patient is diagnosed as tumor, that is person has brain tumor. So we will try using one more image. Click on choose file. We'll upload from the other folder. So I will upload this image. Click on open and now upload it. So this is the uploaded MRI image and it has predicted as no tumor, that is person has no brain tumor. So in this way, just by uploading images to the system, it will detect whether a person has brain tumor or not. Now we'll see graphs of the project. Click on about. So this is accuracy comparison graph, where on x-axis we have accuracy score of each algorithm and on y-axis we have algorithm names. And this is precision score comparison graph. This is recall score comparison graph, and this is FN score comparison graph. Here we have kappa score comparison graph. So here we have Jaccard comparison graphs. Now click on sign out. We have built our project successfully, developing a brain tumor detection system using machine learning techniques, achieving high accuracy and efficiency in identifying tumors from MRI scans. The integration of the voting classifier model into user-friendly interface allows for easy access and automated detection results, demonstrating the potential of technology to enhance medical diagnostics and patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.